Hey everyone, my name is Sai Samant Reddy Konam. I am presenting for Project Investigation 1. The title of my research is AI Driven Quality Governance in Lithium Ion Battery Manufacturing. This presentation outlines the purpose, significance, research design, and expected contributions of my applied research project, which aims to develop a quality governance framework for integrating artificial intelligence into battery manufacturing process. Why this research matters is even a small defect can cause performance failure or safety risks. The zero defect expectation means every stage of production must be traceable and error free. Artificial intelligence, especially through visual inspection systems, promises greater speed and accuracy in quality checks. However, in reality, these AI systems are often face governance and trust challenges. Issues like data bias, inconsistent validation, and lack of accountability when error occurs. Most manufacturing environments also lack a standards framework to manage these risks or to validate AI tools effectively. By addressing these gaps, this research can help strengthen quality assurance, ensure compliance, and enhance stakeholder confidence in AI driven production systems. Coming to the aim and objectives, the overall aim of this research is to develop a total quality management framework that integrates AI governance, assessment, and validation process within lithium ion battery manufacturing. The goal is to ensure that artificial intelligence enhance quality and compliance rather than creating new forms of risk. To achieve this, the study focuses on five key objectives. Coming to the first one is to identify the existing governance and risk management gaps in current AI-based quality system. The second is to examine how stakeholder and change management factors affect the successful adoption of AI technologies. The third is to design a governance model that links risk control directly with validation processes. Fourth is to evaluate key performance indicators such as defects per million opportunities, first pass sale, audit research, and AI adoption rates. And finally, to propose implementation pathways that can guide both industry practices and future academic research. Together, these objectives ensures that the research remains both practical and evidence driven. In the key themes for literature, the first is risk governance. Researchers emphasize the need for strong bias detection protocols, model drifting monitor, and AI auditability standards. These measures ensures that AI systems remain fair, transparent, and consistent over time. Coming to the second theme is stakeholder and change management. Studies show that building operator trust, providing skill transformation programs, and addressing resistance to AI adoption are essential for successful implementation. In the third is validation and compliance. There is a growing focus on adapting traditional qualification processes such as IQ, OQ, and PQ for AI-based systems, integrating ISO 9001 principles and aligning with regulatory requirements. In the final in the final theme, performance and KPIs are concentrated. The literature suggests that using data-driven metrics such as yield improvements and defect reduction helps evaluate how AI contributes to overall manufacturing quality and efficiency. Together, these four themes provide the foundation for developing an integrated AI governance and quality framework. Through a review of the existing literature, one key gap became evident. Most AI research in manufacturing focuses on model performance and engineering accuracy. While these studies are highly technical, they often overlook such systems are actually managed, governed, and validated once they have been deployed in real-life production environment. There is a clear missing link between the technical side of the AI and the managerial frameworks required to control its risks and ensure quality assurance. Very few studies proposed applied management focused frameworks that integrate governance, compliance, and validation into daily industrial operations. This research aims to bridge the gap by developing total quality management based model that focuses not only on how AI perform but also on how it responsible manages managed in practice. In the methodological approach, This research adopts a programmatic approach which balances quantitative evidence with qualitative insights to provide both measurable outcomes and deeper contextual understanding. The design follows a sequential exploratory mixed method structure progressing through the three key phases. In the first phase involves a detailed synthesis of the literature and the development of a survey instrument designed to explore current governance and risk practices of AI-driven manufacturing. In the second phase, it focuses mainly on quantitative survey distributed between 25 to 50 participants working in manufacture, quality assurance, and automation roles. The survey results will highlight measurable trends and common challenges. In the final phase, I'm going to use qualitative interviews with 5 to 8 experts for a deeper interpretation of the survey findings. Together with these three phases, I'll produce an integrated AI governance framework that combines statistical evidence with expert insights to support practical implementation. In the data collection design, it includes both quantitative and qualitative phases. In the quantitative phase, an online questionnaire will be used featuring a 5-point Likert scale to measure participants' views on governance, validation, and risk management practices in AI integration. The target participants are professionals involved in manufacturing and quality assurance role, as they work directly with AI systems and production lines. I expect to collect around 25 to 50 survey responses, which will be sufficient data for statistical analysis and trend identification. In the qualitative phase, I will be conducting semi-structured interviews with industry experts such as project managers, Q&A leads, and automation engineers. Around 5 to 8 participants. These interviews will help interpret the quantitative results in greater depth. Ethical standards will be strictly maintained. All participants' identities will remain confidential and data will be stored securely. In the data analysis and rigor to ensure robust and credible findings, this research helps systematic data analysis methods supported by strong reliability and validate checks. In the quantitative phase, descriptive statistics and correlation analysis will be conducted to identify relationships among variables, followed by cross-tabulation to detect any patterns across participant groups. Tools like SPSS and Microsoft Excel will be used for data processing and visual representation of skills. For the qualitative phase, I will use Brown and Clark's 2006 thematic coding methodology, supported by NVivo 14 software. This will help organize and identify recurring themes, providing deeper insights into stakeholder perspective. Reliability will be tested using Cronbach alpha with a threshold of 0.7, indicating acceptable internal consistency. Internal validity will be achieved through sound construct design, while external validity ensures the results can be generalized to similar industrial context. In the AI quality governance framework, there are four pillar models that have to be considered. The first one is risk governance, which focuses on managing AI model drifts, maintaining comprehensive audit trails, and implementing bias detection protocols to ensure transparency and accountability. Coming to the second pillar, validation and compliance adapts the traditional qualification procedures such as IQ, OQ, and PQ for AI-based systems. It also introduced traceable metrics and regulatory alignment process to verify system reliability. The third pillar is stakeholder and change management, which emphasizes a human factor, role-based training, clear communication plans, and trust-building initiatives that supports successful AI adoption. In the final phase is the performance and KPI pillar. Monitors measurable outcomes such as defect reduction, yield improvement, and audit readiness. Together, these four pillars create a balanced framework that integrates risk, people, process, and performs, aligned with AI system with total quality management principles. In the practical, coming to the practical and academic contributions, firstly, it proposes a standardized AI government model, and in the second one, it enables enhanced decision making where data driven decision approaches improved compliance readiness, reduce human error, and strengthen operational efficiency. In the third one, it provides policy guidance by outlining directions for future AI. And in the and finally, it contributes to the project management discipline by extending traditional frameworks to include governance mechanism for emerging technologies like AI. Coming to the project timeline, it is divided between 13 weeks. In the first week, we mainly focused on literature review, finalizing and synthesis. In the second phase, we mainly focused on how to design survey, pilot testing, and distribution. In the third phase, we interview experts in en vivo thematic coding. In week 10, we assure to develop a data-driven analysis and framework refinement. In week 12 and 13, we are going to do validation of the report. We are going to write a complete data report and do the presentation. Coming to the limitations, there are three limitations. In the first, the study sector context is limited to lithium-ion battery manufacturing. This narrow focus ensures depth but may uh, reduce gener- general stability to other industries in the short term. Coming to the second is a sample size. It's relatively small, which could constrain statistical power and limit how widely the findings can be applied. In the third, it's the time frame, restricted to single semester, preventing long-term data collection and observation. And finally, the framework scope is centered on governance and management process, not on the technical accuracy or algorithmic design of AI model. Despite these constraints, the project sets a strong foundation for future research. It lays the groundwork for a scalable AI quality governance model that ensures trust, accountability, and performance in future industry applications. Coming to the references, these are the key references that we use to establish a strong academic grounds. Thank you.